For today's lesson on parallelograms, you will need a pencil and your geometry note catcher. I'll give you just a little bit of time to get those two materials out. Our lesson today has two goals. The first goal is to determine how is the area of a parallelogram related to the area of a rectangle. If you haven't already written this down, please do so now. All right. How is the area of a parallelogram related to the area of a rectangle? Our second goal is to determine how can we find the perimeter of a parallelogram. All right, so our two goals today: how is the area of a parallelogram related to the area of a rectangle? And how can we find the perimeter of a parallelogram? Before going any further, let's discuss what a parallelogram is. So a parallelogram is a quadrilateral with two pairs of parallel sides. So let's start by looking at the word quadrilateral. And this is a four-sided figure. So squares and rectangles are examples of quadrilaterals. Another word in there I see is parallel sides. So it has two pairs of parallel sides. So let's look down here at this example of a parallelogram. And this shape right here is a parallelogram because it's a four-sided figure. And it also has two pairs of parallel sides. So the top is parallel to the bottom. And parallel means that those lines are never going to cross. Those arrows show us that those two lines are parallel. Also, the sides are parallel, giving us two pairs of parallel lines. So let's talk about our first goal here. How is the area of a parallelogram related to the area of a rectangle? Well, let's check this parallelogram out. We have a couple of letters here, and let's talk about what they mean. We have a B, and that's going to stand for the base of the parallelogram. We have an S, and that's going to stand for the side. And we have an H, and that's going to stand for the height, or how tall the parallelogram is. So when we look at this parallelogram, we see that we can actually manipulate this shape so that it looks like a rectangle. So looking at this shape, we have a triangle on the end over here. And if we take that triangle and we move it to the other side, we now have a rectangle. And we've been practicing how to find the area of rectangles for years. So once again, here's our parallelogram here. If we break apart this shape and then move this triangle over, we have a rectangle. So when we find the area of a parallelogram, our formula is area equals base times height. I want you to take a minute and talk to the person next to you about how is the area of a parallelogram related to the area of a rectangle. You can pause this video. Hopefully with your partner, you talked about that the area of a rectangle was length times width. And so just like a parallelogram, instead of saying length times width, we now have base times height. All right, let's talk about our second goal here, which is how can we find the perimeter of a parallelogram? Well, as a reminder, the perimeter of a parallelogram, or any figure, is the sum of all the side lengths. So it's just adding up all the side lengths. The thing that we have to be very careful about with the perimeter of a parallelogram is that we are only adding up the side lengths and not the height. So looking at this parallelogram, if we were to add up the sides, we would add up the side plus the base plus the other side plus the base. So we would have 4 sides to add up. Make sure to not make the mistake of adding in the height, because that is not one of the sides that goes around the parallelogram. Okay? So here's your equation here. Perimeter for a parallelogram is side plus base plus base. All right, let's do some example problems. We have a parallelogram down here with a base of 10, and please do this with me, 10 inches, a side length of 5 inches, and a height of 4 inches. All right. Now from our work above, we saw that we can move this little triangle on the end over here, so we now have a rectangle. And if we want to find the area of this, we write the equation A equals 10 times 4. Make sure that you have the base, which would be 10, and the height, which would be 4, and not one of the side lengths. So in this case, we would say that the area equals 40 square inches. And we're working really hard with those equations. All right, now we're going to find the perimeter. I'll erase this shape here so we can start fresh. And the perimeter equals side plus base plus base. So in this case, we would have 5 plus 5 plus 10 plus 10. When we add that all together, our perimeter would be 30 inches. Notice that I did not add in the height, which was 4, because that is not a distance around the shape. All right, let's do one more example problem. We have another parallelogram here, and we're going to use the grid to find the area. All right, so looking at this, I'm going to move around a couple parts here in order to find the area on the grid. So I see this part right here. I'm going to start over there. This little part right here that I can move over, and it'll fit nicely in here. which means that I would have a total of 1, 2, 3. I already moved this part over, so we won't include that. Okay? I'm going to pause this video to see if you can use that strategy to find the area of that whole parallelogram. All right. Hopefully you found the area. I'm just going to show you my strategy here. I'm going to continue to try and fill in complete blocks or complete squares. So I have another little part here that I can move over here to have 4, 5, 6, and I already moved over this part here. And then I would have I'm just going to move this part over here. Seven, 8, 9. I'm going to X this out just because I moved it over already. And move over this part right here. And just X that out since I moved that part over. So my answer would be 12 square units, or I could also say units squared. Either one will work. We just have to make sure with area that we're putting our answer in units squared or square units. All right. So it was a little bit tricky to find area on a grid. So instead, let's apply the algorithm that we talked about before. So our first question is, what is the height of the parallelogram to the left? So the height, or how tall this parallelogram is from the very top point to the bottom. So the height, if we were to go to the very top here, switch colors, and draw a line all the way down. So this right here would be the height. Let me erase some of these other figures just so we don't get confused. And I'll delete these triangles as well. So our height would be 1, 2, 3, 4. And even if we were to go here to another the tallest point and draw a line all the way to the bottom, our height would still be 4. 1, 2, 3, 4. So we'll say our height is 4. Oops. Our height is 4 units. All right, our next question is, what is the length of the base of the parallelogram? So that's talking about this distance right here, the base of the parallelogram. And our base is equal to 3 units. So when we use our algorithm, we're going to say that area is equal to base times height. So our area is equal to 3 times 4. So our area here equals 12 units squared, which is the same answer that we got when we counted up the squares, just a little bit more efficient. All right, revisiting our goals from today, we learned how is the area of a parallelogram related to the area of a rectangle, and how can we find the perimeter of a parallelogram.